Hi, Annabelle. Welcome. Today's our very first video lesson from Grandma. I'm so excited. And this lesson is on projectile motion. And the first thing we need to learn about projectile motion equations is that when you throw something at an angle, it has two components, a horizontal, how it goes up and down, and a vertical component, how it goes forward. So we're going to figure that out today, and I'm going to show you how to do that. So let's say you're a baseball player and you're out in center field and you pick up a baseball and you're going to throw it back into the infield. And you throw the baseball at 80 miles per hour at a 50-degree angle. So it's going to go up and it's going to come back down again like projectile motion. So what we need to figure out, though, is how fast was it going forward and how fast it was going up and down. It was going 80 miles per hour diagonally. But we need to break that up into the up velocity and the forward velocity. So let's kind of break that down. If you have an angle like this, how fast is it going up and down, and how fast is it going forward? These two add up to be this vector in the middle. Now you can do this math with something called trigonometry, but that's pretty complicated math for a 14-year-old. So we're going to go and use our protractor and a ruler to do it instead. And then later on, when you get to trig in math, you'll be able to do this with trigonometry, and you won't need the protractor or the ruler then. But today we can use these to figure out how fast was it going up and how fast was it going forward. Because the up and down motion, remember, from the exploration we did, is different than the forward motion. The forward motion stays constant, and the up and down motion accelerates due to gravity. So as you throw it up, gravity is pulling it down, so it slows down, and as it falls, it speeds up because gravity is pulling it down, but the forward motion stays the same unless a force acts upon it. So we want to divide this up. So I know it's going at this angle, 60-degree angle. Probably doesn't look like 60-degree angle there. 60-degree angle 50-degree angle. 50-degree angle, it's going 80 miles per hour. So I'm going to draw that vector a little bit bigger so you can really see that. So I'm going to put a dot here. And that's going to be our starting point. And I want to go at 50 degrees angle. So I'm going to take my protractor and put it on the dot, the center dot on the dot. I'm going to put that on the dot and mark where it's at 50 with a little line. So it's going to be 50 right here, and right here is 0 degrees. Then I'm going to take my ruler and connect the middle dot here and draw a line from the middle dot here. And this would be the forward direction going this way. Now I have to draw this to scale so I can use these lines and not just have them at any length I want. I have to make up a scale. And I need a scale that I can use 80 miles per hour with. So 80 miles per hour, so that you can see it on the screen, I can set 10 miles per hour equals 1 inch. And for this example, we probably want to be using meters per second and centimeters, but I thought we'd talk about baseball because it's almost baseball season. So we are going to use miles per hour for this. So I want this line to be 8 inches long. Oh, I almost got it exactly just by drawing it out. 8 inches is right here. So this is my vector. This is how I'm throwing the ball. This is a 50-degree angle. And this is 8 inches long. So now I need to know how much is the speed going up and how much is the speed going forward. All right. So I need to divide this into two vectors. So this vector can be added up as to a velocity vector that goes forward. So I just drew this I took this and went down 90 degrees. I kind of eyeballed the 90 degrees, but if you have your protractor out, you might as well get that out and go down 90 degrees. So there's the 90. And you're going to draw this little triangle. So here is the actual baseball going here at 80 miles per hour, but it's moving upwards at a speed of from here to here. So now what is that speed or velocity? Velocity includes the direction. So now I get out my ruler and I measure it, and it's at 6 inches. So 6 inches is 60 miles per hour. So it's traveling upwards at a rate of 60 miles per hour, and it's traveling forward at a rate of 5, I'm going to estimate 5.5 inches, which is 55 miles per hour this way. All right? So if you want to figure out how fast a projectile is moving forward and how fast it's moving upwards, when you're given the velocity at an angle, you can draw this triangle. You first draw the 80 miles per hour at 50-degree angle, and then you make it into a triangle. This plus this, if you remember adding vectors, gives you this, right? So go do that at home and try that out. So draw one that goes at, let's change it to 50 meters per second at a 30-degree angle. And you may not have a protractor at home, so probably come get one at my house and then take that home as part of your homework. We'll talk to you later. Hope you're enjoying physics. Bye.